angle is missing, you go to its arc. I like that. Do we know what the arc is? No. We have to find out what that arc is. But I'm noticing in this diagram that there's this other angle that's intercepting that same arc. And what kind of angle is this purple angle? Is it central or inscribed? Inscribed. Why is it inscribed? Because it's on the edge. The vertex is on the edge. Well, what do we have to do? Remember from yesterday, what do we have to do with this angle to get that arc? I think we're going from a little angle to a bigger arc. Times it by 2. So when we multiply our inscribed angle by 2, what's the measure of that arc? 82. Okay. Now that we know what this arc is, we can easily figure out what that angle is because it's central. And what do we know about this central angle in the arc? It's the same. So if the arc's 82, that means the angle is going to be 82. So x is equal to 82. You could have used this property and said, oh, I'm missing my central angle. I know my inscribed angle is half my central, so I just double it. And when you double 41, that gives you 82. If you don't remember that property, I like to think of it more as a shortcut. You can just do all the work we just did and you're still going to get the right answer. Remembering these properties just makes work a little less. Makes your life a little easier. But if you don't remember them, it's not the end of the world. Okay. If we take a look at B, we want to find x, and x is inside this purple angle. So whenever an angle is missing, go to the arc. Do we know what that arc is? No, but how can we find it? Trent? Yeah, I noticed this angle right here is intercepting that same arc, and that angle is what type of angle? Central. And what do we know about the central angle in the arc? They're the same. So as Trent said, that arc's going to be 162 because the central angle is 162. Now that we know what the arc is, we can find the angle. Well, what type of angle is this purple angle? Central or inscribed? Inscribed. So we're going from big arc to little angle. What do we have to do with the 162? Divided by 2. Cut it in half, and that will give you the inscribed angle. What's 162 divided by 2? 81. So that angle, or x, is 81. So it's kind of combining the two things in one problem. Again, if you remember that property, that an inscribed angle is half the central angle when intercepting the same arc, you could have saw that the central angle was 162. We'll cut it in half, and that will give you 81. Okay. Questions over that? Again, if you don't remember the property, as long as you do the math, you're still going to get the right answer. Another important property is that an angle inscribed in a semicircle is always 90. Meaning when you have an inscribed angle and its intercepted arc is a semicircle, that inscribed angle is always going to equal 90. And we're going to jump around a little bit. We're going to do B first and then move on to A, because B's a little easier to start with. So we take a look at B first. We want to find the value of B. We don't really know the arc, but I notice it's inside this triangle. So if we can figure out what this other angle is, we can easily find B. So when an angle is missing, we're going to find this angle right here. Go to the arc. What type of arc is that? What's the special name for that arc? The semicircle. What do we know about the measure of a semicircle? It's 180. Well, what type of angle is this angle right here, inscribed or central? It's inscribed because it's on the edge. So what do we have to do with 180? We're going from big arc to little angle. Divided by 2. So I do 180 divided by 2. What do we get? 90. So if you remembered that property, you could see, oh, I have an inscribed angle. Its intersected arc is 180. automatically 90 degrees. That's what that property is saying. Again, if you don't remember that property, it's not the end of the world, and still get the right answer. Okay. Now that we know what this angle is, what do we know about all the angles of a triangle? What do they add up to? 180. So what can we do with 90 and 60 to figure out what B is? Add them and then subtract them from 180. And that will give us angle B. So when we subtract those angles from 180, B is equal to what? 30 degrees. Questions over that. If we take a look at A, now we're going to jump to A. Similar thing, but a few more trickier steps. We want to find the missing variables. So we want to find A, we want to find B, and we want to find C. Alright? Well, if I find angle A first, the angle's missing. Go to the arc. What type of arc is that? A semicircle. What do we know about the measure of a semicircle? 180. Alright? Someone new. If you're like the same person answering the same question. What do we have to do with 180 to figure out what A is if we're going from big arc to little angle? Divide by 2. What's 180 divided by 2? 90. Again, if you remember that property, you could have said, oh, inscribed angle, its arc's a semicircle, automatically 90 degrees. It saves you some work. You remember that fact. If you don't, not the end of the world. Okay. Now we want to find angle B. This green angle right here. Well, if an angle's missing, go to the arc. Well, its arc is also missing. Okay? Is there a way we can figure out what that arc is? How can we figure out that arc? Yeah, very good. If you notice, this is a semicircle. And we know part of that semicircle is 124. So we can just do 180 minus 124, and that will, oh, that should be for C. Sorry. That's for C. If we do 180 minus 124, that will give you the rest of that arc. Well, what is 180 minus 124? What do we get? 56. So then I know C is 56. Now that we know what C is, what can we do to 56 to find B if we're going from big arc to little angle? Divide it by 2. What's 56 divided by 2? 28. So there is the measure of all three of those missing variables. Questions over that? Last one from this property, if we take a look at C, we want to find X, and I notice X is inside this angle. So whenever an angle is missing, go to the arc. What's special about that arc? It's a what? It's a semicircle. What's the measure of a semicircle? 180. Well, this semicircle is 180. What's the measure of that angle? 90, because you cut it in half. It's an inscribed angle. You cut the arc in half. So I know this angle is 90. But I also know that angle is 2x. And we have an expression. Whenever we have an expression, what can we do? We have to set up an equation. How are we going to set up an equation to figure out what x is? What did you do? Yeah, very good. We're going to set them equal. If I know this angle is 90, I also know this angle is 2x. We can say 2x is equal to 90. And then solve. When we solve, what do we have to do with that 2? Divide. So when we divide, what's 90 divided by 2? 45. So x is equal to 45. Questions over that? Okay, so the properties on the front, you don't have to necessarily remember them exactly. You can do some math and still get the right answer. But this property on the back, when you flip it over, you have to remember what this is. Okay, this is a really important one. You have to remember this fact. Okay? The opposite angles of a quadrilateral inscribed in a circle are supplementary. What does supplementary mean? They add to 180. So whenever you have a quadrilateral inscribed in a circle, meaning the vertices are all inscribed angles, they're on the edge of the circle, the opposite angles always add to 180 degrees every single time. That's an important fact to know. Okay? So we take a look at this example. We want to find x, and we want to find y. Okay? Well, I notice I have a quadrilateral, so I'm going to find its opposite angle. What angle is opposite of x? What angle is opposite of x? Across from. 80. So what can we do? If I know these are supplementary, what can we do with 80 to figure out what x is? We know that opposite angles of a quadrilateral are supplementary. That means they add to 180. Right? Well, what can we do with 80 to figure out x's? Subtract them. You can just do 180 minus 80, and that will give you x. What is 180 minus 80? 100. And you can double check. 100 plus 80 gives us 180. We're good. So to find y, we do the same thing. What angle is across or opposite of y? 71. So you do the exact same thing. You just do 180 minus 71, and that will give you y. What is 180 minus 71? What is it? 109. So the measure of y is 109 degrees. So that is an important thing to remember. We have a quadrilateral inscribed in a circle. The opposite angles add to 180. If it's just like this, you just subtract the opposite angle from 180, and that gives you the answer. If we take a look at B, we want to find x. Well, here's x. Well, when an arc is missing, go to the angle, but there's not really an angle intercepting that arc. Okay. But I know if I extend this to here, now there's an angle that's intercepting that big arc. Okay. This angle right here. We can figure out what that angle is. That will help us figure out what x is. How can we figure out what that green angle is? How can we figure out what angle r is? What do you do the opposite? Yeah, very good. I have a quadrilateral. And 110's across from it. What can we do with 110 to figure out what r is? Good, subtract it from 180. So when we do 180 minus 110, what does that give us? 70. Well, if I know this angle is 70, what do I know about the measure of this entire blue arc? It's what? What is it? Well, is this angle, green angle, inscribed or central? Inscribed, because it's on the edge. What do we have to do with the inscribed angle to find the arc? We're going from little angle to big arc. Yeah, multiply it by 2. We double it. So I know the measure of this entire arc is 140. And I know these two pieces make up that entire arc. So how can we figure out what x is? What equation can we set up? Okay. Very good. You can add the two arcs together. Because I know if I take this arc and add it to that other arc, if I add 30x and 50 together, it will give us 140. So then we just solve it like a normal equation. We move the 50 over. 140 minus 50 is what? 90. So we get 30x is equal to 90. And then what do we do with the 30? Multiply it, so we divide. What's 90 divided by 30? 9 divided by 30 is what? 3. So x is equal to 3. Okay. Questions over that? Okay. At the bottom, we're going to talk about one new type of angle. And that is called a circumscribed angle. Okay, and a circumscribed angle is an angle formed by two tangent lines. So if you look at this diagram below, that is a tangent to the circle because it's touching the circle one time on the outside. The other side of this angle is also tangent because it's touching the outside of the circle one time. It's called a circumscribed angle. Kind of looks like an ice cream cone a little bit. You kind of have a diagram that looks like an ice cream cone. That's a circumscribed angle. You have an angle on the outside, and then the circle's kind of sitting on it like a scoop of ice cream or a snow cone. And then there's this theorem. It says the measures of a circumscribed angle and a central angle that intersect at the same points on a circle are supplementary, which again means they add to 180. Okay. So we look at these diagrams below. I notice I have this circumscribed angle because again it looks like a tennis racket or ice cream cone or something. And it's intersecting the central angle at the same exact points on the circle. So it's making a four-sided figure. Okay? It looks kind of like a kite or a diamond, however you think of it. So whenever we have this shape, what I know about the two angles, the central angle and the circumscribed angle, what do these two angles add up to? 180. So what can we do with 117 to figure out what x is? Subtract it. Just do 180 minus 117, and that gives us what? What is it? 63. Okay. So I know x is equal to 63. Correct? Yeah. Little rule of thumb here, when you're dealing with circles, and you have lines like inside or outside of the circle, and they're creating a four-sided figure, four-sided figure, four-sided figure, the opposite angles are always going to add to 180. So if you have a four-sided figure and you're dealing with a circle problem and you don't know what to do, just subtract the opposite angle from 180 and you're probably right. Right. And the last one. If we take a look at B, we're trying to find this missing angle right here, which is a circumscribed angle. So I'm going to look at its central angle. Do we know what that central angle is? No, so we have to find it. How can we find the measure of that central angle, Trent? Yeah. Very good. This other angle they gave us, this purple angle right here, is an inscribed angle. And it's intersecting the exact same arc as the central angle. So using that shortcut on the front, using the shortcut that Trent used, just double your inscribed angle, and it gives you your central. So when we double 30, what does that give us? 60. So now that I know what that central angle is, what can I do with 60 to find the circumscribed angle? Subtract it from 180. Because we have a four-sided figure, opposite angles are going to add to 180. So let's do 180 minus 60. And what does 180 minus 60 give us? 120. So again, if all else fails, you have a four-sided figure dealing with circles. They add to opposite angles are going to add to 180. Subtract from 180, you're probably okay. Questions over that? Rest of the time is yours. First.